Hi everyone, good afternoon. Myself M S Mustafaa, Mohammed Shahnawaz Mustafaa. I have completed my MSc in collaboration with Cranfield University of United Kingdom in clinical research in 2010. I have also done BSc in chemistry and zoology from Rohilkhand University of Bareilly, UP, India. I have also done B.Ed in 2018 in Mathematics and Science from Himgiri University of Dehradun, Uttarakhand, India. I have also obtained an online certificate course of Python language. So I have also command on Python language, programming language of computer. I have more than 16 years of teaching experience online as well as offline. I have worked for 5 years with an academy. Where I taught mathematics, science and reasoning for the competitive student and also academic students. So I have worked for different organization, different institute, different schools. So I have more than 16 years of teaching experience. Subject that I can teach, so I have command on mathematics, so I can teach mathematics up to class 10th. Also physics and chemistry, I have command on physics and chemistry up to class 10th. And as I have done my BSc in chemistry and zoology, and I have also done my MSc in clinical research, so I have command on biology up to class 12th, and I can also take NEET aspirants. So I can also teach Python language for computer science student, and I have also command on reasoning for competitive examination. Reasoning topic just like blood relation, clock, calendar, coding, decoding and syllogism. So all the topics of reasoning I can take. I have also command on reasoning. I can teach reasoning also. So what are my skills? So I have already told you that I have command on almost all topic of mathematics up to class 10th. I can take mathematics up to class 10th. I have also command on Vedic mathematics, means fast calculation. So I can teach students how we can find the square of any number, two digit number or 1 digit number or 3 digit number in just a few seconds. So I have command on square root also, how we can find out the square root of any numbers within few seconds, cube and cube root also, and I can also teach students how we can multiply 2 digits number, 3 digit number in a very easy and fast way. So I can teach both in Hindi and English language. So I have command in English and Hindi both. So I can teach in both language. I always focus on each and every student. Actually, I believe that every student is important for me. So I always focus on each and every student. So I always try to make clear all the concept to each and every student. I have excellent teaching skill both online and offline. So mathematics, if we talk about the mathematics up to class 10, so we have different branches of mathematics. So up to class 10th we have arithmetic, in which we have topics just like number system and calculation and simplification, LCM HCF, we have percentage, profit and loss, simple interest, compound interest, and we have ratio, we have average, we have speed, time and distance, and we have time and work. Then if we talk about the advanced mathematics, then we have geometry, we have trigonometry, we have algebra, we have data interpretation, we have permutation combination, set theory. All these these are the topics up to class 10th. So we have geometry. So I always start geometry from zero level, right? I start geometry from point. Then point, after points we have lines, after line we have polygon, then triangle, then square, triangle. After that we have quadrilateral, then pentagon, hexagon, circle. So I always teach from zero. Then we have trigonometry also. So in this particular video I will cover, actually it is a demo of mathematics. So I will cover some topic of arithmetic like number system and LCM and HCF. I will also cover some portion of geometry from very basic means from 0, from point, and I will also explain, I will also introduce, I will also give a brief introduction of trigonometry, like what is trigonometry and what we study in trigonometry. And algebra etc, these are the topics of mathematics up to class 10. So I have almost command on all these topics. Number system is one of the most important topic, and it is a little bit confusing topic also. Actually it is a vast topic. It is a very vast topic. We have different types of number. So if we talk about from where we start number system, so I always start number system from very basic. So first we will discuss what are the real numbers, what are imaginary numbers, then what are the basic digits. So we know that in mathematics we have only 10 basic digits, 0 to 9. Then we have natural numbers, then we have whole numbers. What is the difference between natural numbers and whole number? Then we have integers. In integers we have positive integers, we have negative integers, we have 0. Then we have even numbers, we have odd number. What is the basic difference between even numbers and odd number? Then we have prime numbers, and in prime number we have different category also, right? In prime numbers we have different category also. That's why the student face so much of confusion in number system. So we have prime, we have co-prime numbers, we have relatively prime numbers, we have twin prime numbers. After that we have perfect number, deficit number, abundant number, then triangular number, then we have rational number, then we have irrational number. So these all are the topics we cover in number system. Then we have decimal, and in decimal we have some categories like terminating decimal, non-terminating decimal. In non-terminating decimal we have two categories. We write in non-terminating decimal like non-terminating decimal, non-terminating recurring decimal, and non-terminating non-recurring decimal. After that we have binary numbers and we have Roman numbers. How we can convert decimal into binary, and how can we convert decimal into binary and from binary to decimal. Then we have Roman numbers. How we can convert Roman numbers into Indo-Arabian numbers like English numbers, right? How we can convert decimal number into Roman or Roman number into decimal number or English system, right? So we have Indian system, we have international system, we have Indo-Arabic system, right? So I will cover all these topics. Now if we start from real numbers and imaginary numbers, so students face so much of confusion that what are the real numbers and what are imaginary number. I have already told you that I always believe on concept. Actually mathematics is not a subject of memorization or rectification. Mathematics is all about the concept. If the educator clear all the concept of the student, then student will not face any difficulty in mathematics. If student clear all the concept related to any subject, any topic of mathematics, then mathematics will be a piece of cake for them. So I always focus on concept. I always try to clear all the concept of the students. Then they will not face any difficulty. If examiner ask any question from any corner of the topic, student give the correct answer if they clear their concept, right? So now we will discuss about real numbers. What are real numbers and what are imaginary number? I will give the brief introduction of real numbers and imaginary number, right? If we have n as a number, and we have to decide whether is a real number or imaginary number. So how we can determine, how we can find that any number n is a real number or imaginary number? Actually, if you take the square of n, right? If n is a number, and if you take the square of n, and what is the square? The number multiply by itself, right? What is the square? For example, square of 2. So 2 into 2 is the 4 is the square of 2. If you want to take the square of 3, then 3 into 3 will give you 9. It is the square of 3. So any number you want to determine whether it's a real number or imaginary number. So what we have to do, we have to just take the square of that number. If we are getting a positive value, then our number is a real number. And if we take the square of n and we are getting a negative value, then the number will be our imaginary number. Now if we take some example, then it will be clear to us. For example, we have -4 and we want to know whether it's a real number or imaginary number. So what we do, we will just take the square of this -4, and you know that -4 into -4 will give you 16, and it is a positive number. That means -4 is a real number. It's a real number. If you take the square of 4 will give you also 4 into 4, it will also give you 16. That means this +4 is also a real number, right? So these are the real number. Any number which give positive integer on squaring is a real number. On other hand, if you take a square of any imaginary number, it will give a negative integer. For example, under root -1, right? Under root -1, it is an imaginary number. How is an imaginary number? Just take the square under root -1, take the square of this under root -1. So this will give you under root -1 into under root -1, right? This will give you -1, and this is an imaginary number. Actually, this under root -1 is nothing but it is just called iota, and iota, you know that it is an imaginary number. Iota is an imaginary number. So any number which is associated with iota is an imaginary number. For example, you have -7. So what is -7? It is just -1 into -7. Sorry, -1 into 7. So -1 into 7. So this is -1 under root -1 and into under root -7. So this number, this iota, is an imaginary number. That's why under root -7 is also an imaginary number. Clear? So I think that this topic is clear to you. So, and if you want to determine whether any number is an imaginary number or real number, just take square of that number. On squaring, if you get a positive value, then the number is a real number, and if on squaring you are getting a negative value, then the number is an imaginary number. So just remember, if you have any number within the square root and it is with negative sign, that particular number is an imaginary number. So if whenever examiner want to know, examiner give you any question and examiner want to know which of the following is an imaginary number or which of the following is an real number, so you can easily find out. Just take the square of that number. If you are getting positive value, then the number is real number, and if you are getting a negative value, then the number is imaginary number. So this is all about real numbers and imaginary number. Now we have basic digits. So how many basic digits we have in our mathematics? So in mathematics we have only 10 basic digits. These start from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are only 10 basic digits in our number system. These are only 10 basic digits in our mathematics, and with the help of these basic digits we can make any number, any 3-digit number or any 2-digit number or any 4-digit number, any 5-digit number, any 6-digit number. Now question can be arise, how many 1-digit number we have? So we have only 9 1-digit number, 1 to 9, right? We have only 9 1-digit number, 1 to 9, right? And smallest 1-digit number, if examiner want to know is smallest 1-digit number, so smallest 1-digit number is 1. And if examiner want to know the largest 1-digit number, so the largest 1-digit number will be 9, right? So this is all about 1-digit number. So total 1-digit number 9, smallest 1 and largest 9. If examiner want to know 2-digits number, so total 2-digits number is 90, and if you want to take the smallest 2-digit number, it will be smallest 2-digit number is 10, and if you want to take the largest 1-digit number, 2-digit number is 99. Just like this we can find out the 3-digit number. Total 3-digit number is 900, and smallest 3-digit number is 100, and largest is 999. For example, 4-digit number, total 4-digit number will be 9000, and the smallest 4-digit number is 1000, largest 4-digit number is 9999. So you can easily find out the total number, total 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, right, whatever, and smallest. So just take, if the examiner want to know smallest 1 digit number, so just is 1, smallest 2 digit number 10, 3 digit number 100, 4 digit number 1000, 5 digit smallest number 100, and largest number is 9, 2 digit largest number 99, 3 digit largest number 999, 4 digit largest number 9999, and 5 digit largest number 9999. So like this you can find out 1 digit, 2 digit, 3 digit, 4 digit, 5 digit, whatever examiner want to know, you can easily find out. So in this way we can make out the number with the help of basic digits, right? So this is all about the basic digits. So how many basic digits we have? We have 10 basic digits. 1 digit number we have 9, smallest 1 digit number is 1, and largest 1 digit number is also 9. 2 digit numbers we have 90, smallest 2 digit number is 10, and largest is 99. So you can make out any question, you can give the answer of any question. So this is all about the basic digits. Now we have natural numbers. We have natural number. If a student clear all the concept of number system, then number system will be very easy to them. And if they clear all the concept of number system, if they clear the topic number system and LCM HCF, ratio and percentage, then arithmetic will be a piece of cake for them. So just focus on 4 important topic: number system, LCM HCF, percentage and ratio. Then all other topic will be very easy to you. Arithmetic will be in your pocket. Arithmetic will be a piece of cake for you. Now natural number. What are the natural numbers? So if we take the definition of natural number, you will get in 6th class. Natural numbers are the numbers which help in counting, or you can say that all the counting numbers are natural numbers. All the counting numbers are natural number, and you know that our counting starts from 1. So smallest natural number is 1, and largest natural number, you can say that infinity, or you can say cannot be determined, because there is no limit of counting. So natural numbers, what are natural numbers? The natural numbers are the number which help in counting, and you know that counting starts from 1. So 1 is 2 and 3 and 4 and 5 and 6 and 7 and 8. So natural number is also a very important topic, and it is also a vast topic. So I will explain when I cover complete mathematics. But you can visit my YouTube channel, Learn with Mustafaa, in which so on that channel you will get complete number system, but you will get complete number system in Hindi language. So I will soon record, or I will soon come live with the English version of number system. So you can visit my YouTube channel and you will get complete number system but in Hindi language. So text you will get in both in Hindi and English language, but the explanation is actually not in Hindi, it is English, is a mix. So English plus Hindi is called English, right? So I will explain complete natural number. So when we describe number, when we take complete topic, then I will explain natural number. Now we have, so smallest natural number I have already told you 1, and the largest natural number cannot be determined, as you know that there is no limit. Now if you want to take the difference between 2 consecutive natural numbers, so the difference between 2 consecutive natural number is always 1. So we have different type of questions. So examiner can ask different type of question. Find the sum of first 20 natural number, find the sum of first 50 natural number, find the sum of first 60 natural number. So we will discuss some important formulas for all these numbers. Now we will take whole numbers. Now what are whole numbers? So we have already discussed about the natural numbers. So what is the difference between whole numbers and natural numbers? So natural numbers, I have already told you that the natural numbers are the number which help in counting, and they starts from 1 and up to infinity, or you can say that the largest natural number cannot be determined. But in our basic digit we have also include 0, but in natural number we don't include this 0. So if we include 0 in natural number, then these numbers are called whole numbers. These numbers are called whole number. So whole numbers start from 0 and natural numbers start from 1. So if examiner want to know which of the following is the smallest whole number, so the answer will be 0, and largest whole number again cannot be determined, right? This is all about the whole numbers. So this is just introduction of whole number and natural number. Clear? Next topic we have natural numbers, whole number. Not next topic we have integers, right? So you have learned about the number line. So the representation of all the numbers on the number line, right? So you know that at the middle of number line we have 0. 0 is a neutral number. Neither is a positive number sorry guys, nor it's an negative number. Actually 0 is an neutral number. So on the RHS of 0 we have all positive integers. On the LHS of 0 we have all negative integers. I have already told you 0 is neutral. 0 is neutral. So on the RHS we have we have all positive numbers. On LHS we have all negative numbers. So 1 is the smallest positive integers and plus infinity is the largest positive number. And here we have minus 1 is the largest negative integers and minus infinity is the smallest. As you know, if we move from left hand side, if we move, so this is all about the integers. Positive number, if we talk about the positive number, so smallest positive number is plus 1 and largest positive number is plus infinity or cannot be determined. If we talk about the negative integers, so largest negative integer is minus 1 and smallest either is negative infinity or cannot be determined, can't determine. So this is all about the positive and negative integers. So we have lots of question on this topic also, positive integers and negative integers. So this is all about positive and negative integers. Now we have even numbers and odd numbers. So we can define even numbers in 3 ways, right? So all the number sorry, all the numbers which are the multiples of 2, which are multiple of 2. This is the first definition. All the multiples of 2 are the even number. Second is numbers which are divisible by 2. वो सारे नंबर जो 2 से डिवाइड हो जाते हैं, राइट? ऑल द नंबर्स विच आर डिविजिबल बाय 2, all the multiples of 2 are even numbers. For example, 2 is an even number, 4 is an even number, 6 is an even number, 8 is an even number, 10 is an even number, 12 is an even number, 14 is an even number, 16 is an even number, 18 is an even number, right? On other hand, the definition of odd number. So the number which are non-multiples of 2. I will explain multiples also. Multiple, non-multiple of 2. All the non-multiples of 2, or we can say that the number which are not divisible by 2. Not divisible by 2. All the number which are not divisible by 2. For example, we have 1, we have 3, we have 5, we have 7, we have 9, we have 11, we have 13, we have 15. So these all are odd numbers. So the common difference between even numbers and odd number is same. So the difference between two consecutive even number is 2 and the difference between two consecutive odd number is also 2. We have lots of question on even numbers and odd numbers also. We will explain. Now if we talk about 0, right? 0. So if you talk about 0, so 0, what is an even number or an odd number? So 0 is an even number. 0 is an even number. How we can say that 0 is an even number? For example, we have 16, we have 20, we have 22, we have 14. Right? You know that the difference between two consecutive even number and odd number is always 2. So if you subtract 2 from an even number, we have any even number, and if you subtract 2 from any even number, you will get an even number. Clear? So if you subtract 2 from 20, you will get 18. 18 is an even number. If you subtract 2 from 18, you will get 16. 16 is an even number. If you subtract 2 from 16, you will get 14. 14 is also an even number. If you subtract 2 from 14, you will get 12. And 12 is an even number, and so on. If you subtract 2 from 6, you will get 4. 4 is an even number. If you subtract 2 from 4, you will get 2. 2 is an even number. And now if you subtract 2 from 2, you will get 0. So in this way we can say that 0 is also an even number. So this is the first way. I have explained that 0 is an even number. Another way, we know that if we add two even numbers, right? For example, 2 plus 4, we get an even number. Clear? If we add two odd number, for example 3 plus 7, we get an even number, right? 10. So if we add two even number, the result will be an even number. Even plus even, the result is also even. Clear? If we add two odd numbers, the result again is an even number. And if we add an even number plus an odd number, right? For example, 5 plus 4, the result will be 9. That means an odd number. Clear? So even number plus even number will give you an result will be an even number. Odd number plus odd number will give you result will be an even number. And if you add even number with odd number, the result will be an odd number. Now, for example, we considered that 0 is an odd number. Now let us consider, let's suppose if 0 is an odd number, then what will be the result? Now we just considered that, let us suppose 0, we have considered that 0 is an odd number. Now if 0 is an odd number, if we add even number plus odd number, the result must be odd. The result must be odd. If we considered 0 as an odd number, so if we add even number plus odd number, the result must be odd. Now let us suppose we have 4 is an even number and we have considered 0 as an odd number. So if you add 0 to this 4, the result will be 4, and 4 is an even number, right? So our we have considered that 0 is an odd number, but this is not satisfying the condition. So that's in this way we have proved that 0 is an even number. Now just take, if we considered 0 is an even number, so we take 2 and we take 0 as an even number, the result will be 2, which is an even number. Clear? So I hope this concept is also clear to you, that 0 is an odd, so 0 is an even number, not an odd number. I have explained with two examples. Next, so we have discussed about the even numbers, odd number. Now we have very important topic, which is prime number. Very important topic, prime numbers. So if you clear the concept of prime number, right, then arithmetic will be very easy to you. This is a very important number. So if you clear the concept of prime number, right, so how we can clear the concept of prime number? For this we have to just focus, we have to just learn the factors. A very important concept, factors. So what are factors? What are factors? So just define factor. Factors of any numbers, factors of any number which can divide that number. very important concept. Factors and multiples are two very important concept. If you clear this concept, then LCM and HCF will be very easy to you. Now what are prime numbers? So first we have discussed what are factors. So factors of any numbers are the number which completely divide of that particular number. Now we will take some example. If we take 6 so the number which completely divide 6 are the factors of 6. The numbers or digits which completely divide the 6 are called the factors of 6. So 6 is completely divisible by how many numbers? So you know that 1 can divide any number. 1 is the universal factor of any number, any natural number. 1 is the factor of all the natural number, we can say that, right? So 2 is also a factor of 6, 3 is also a factor of 6, and 6 is also a factor of 6. So these are the 4 factors of 6. Clear? Hai? So these are the factors of 6. Any number, so factors of any numbers are the number which completely divide that particular number, right? So these are the called factors of any number. So with the help of by the definition of factors, we can define the prime number. So what are prime numbers? Prime numbers are the number that has only 2 factors. Has only 2 factors. Any number which has 2 factors, or we can say that any number which is divisible by only 2 numbers are called prime numbers, right? We have lots of prime number. We have lots of prime number. We have 165 prime number from 1 to 1000. Clear? I will explain again. So what are prime numbers? Prime numbers are the number which has only 1 factor. We have a very important theorem here. The theorem of arithmetic. Very important theorem. FTA. FTA. What is FTA? This is just fundamental theorem of arithmetic. So what is this theorem? Fundamental theorem of arithmetic. So this theorem says that except one, all the natural numbers, the fundamental theorem of arithmetic, except one, all the natural numbers are either prime numbers, and we have already discussed what are prime numbers. The prime numbers are the number which has only 2 factors, or the numbers which are divisible by only 2 numbers. So all the natural numbers except one are either prime numbers or product of prime numbers. Very important fundamental theorem. So with the help of this theorem, we can explain any natural number, right? So what fundamental theorem says? Fundamental theorem says that except one, all the natural numbers are the prime numbers or the product of prime number. So just leave this one. Except one, we have 2. You know that 2 is a prime number. X, it is divisible by only 2 numbers, 1 and 2 itself. Now we have 3. 3 is also a prime number. It is divisible by 1 and 3. Now we have 4. So 4 is not a prime number, but it is a product of prime number. 2 into 2, it is the product of prime number. Now 5. 5 is also a prime number. Now we have 6. 6 is not a prime number, but is the product of 2 prime number. 2 into 3. Now we have 7. 7 is a prime number. Now we have 8. 8 is not a prime number, but it is the product of prime numbers. 2 into 2 into 2. Now we have 9. 9 is not a prime number, but it is also the product of prime number 3 into 3. Now we have 10. 10 is also not a prime number, but it is also the product of, 2 prime number 2 into 5. Now 11. 11 is a prime number, right? And it is a very important concept regarding 11. It's a very important concept. 11 is the only prime number whose all digits are same. 11 is the only prime number, 11 is the only prime number whose all digits are same. All digits are same. So 11 is the only prime number whose all digits are same. Except 11, there is no prime numbers whose all digits are same. So we have 1, 1, 1. It is not a prime number. We have 2, 2, not a prime number. 3, 3, not a prime number. 4, 4, not a prime number. 5, 5, not a prime number. 6, 6, not a prime number. 7, 7, not a prime number. So this is all about the prime number. So prime number is also a very vast topic. I will explain when I will take the complete mathematics. Then I will explain all the concept of prime number. But very, very, very important concept regarding the prime numbers. So we have discussed what are the prime numbers. So prime numbers are the numbers has only two factors, or the numbers which are divisible by only two numbers are the prime number. Their one factor is 1 and other factor is number itself. Clear? So another definition of prime numbers: except 2 and 3. Except 2 and 3. So I will write some prime numbers here, then this concept will be clear to you. So we have prime number, we have 2 is a prime number, we have 3 is a prime number, we have 7 as a prime number, we have 2, 3, 5, 7 is a prime number, we have 11 as a prime number, then we have 13 as a prime number, then we have 17 as a prime number, 19 as a prime number, then we have 23 as a prime number, then we have 29 as a prime number, then 31 as a prime number, then we have 37 as a prime number, then 41 as a prime number, then 43 as a prime number, then 47 as a prime number, then we have 53 as a prime number, then we have 59 as a prime number, then we have 61 as a prime number, 67 as a prime number, then we have 71 as a prime number, then we have 73 as a prime number, 79 as a prime number, then we have 83 as a prime number, then we have 89 as a prime number, then we have 97 as a prime number. So these are 25 prime number. From 1 to 100 we have 25 prime number, and 1 to 50 we have 15 prime number, and 51 to 100 we have 10 prime number. Right, these all are prime numbers from 1 to 100. Now you can see here very important pattern. You can observe here very important pattern: except 2 and 3. So if we exclude 2 and 3, every prime number, you can see here 5, 7, 11, 13, 17, 19 or 23. Every prime number except 2 and 3 is near any multiple of 6. Near any multiple of 6. Just see 5. 5 is 6 minus 1. The first multiple of 6 is 6, 6 minus 1. This is 6 plus 1. This is second multiple of 6. Second multiple of 6 is 12. This is 12 minus 1. This is 12 plus 1. This is 18 minus 1. 18 plus 1. 24 minus 1. 30 minus 1. 30 plus 1. 36 plus 1. 42 minus 1. 42 plus 1. 48 minus 1. 54 minus 1. 60 minus 1. 60 plus 1. 66 plus 1. 72 minus 1. 72 plus 1. 78 plus 1, 84 minus 1, 90 minus 1, 96 plus 1. So all the multiples, all the prime numbers except 2 and 3 are near any multiple of 6. You can say that all the prime numbers except 2 is either 6 into n plus 1 or 6 into n minus 1. N is any natural number, right? So you can see here any prime number except 2 and 3 is any near the multiple of 6, either 1 less than the multiple of 2, multiple of 6, or we can say that either 1 greater than the multiple of 6. Clear? Now we have another definition. So if you divide any prime number by 6, if you divide any prime number by 6, you will get remainder either 1 or 5. Any prime number, if you divide any prime number by 6, you will get remainder either 1 or 5. But I am not saying that every number which is giving remainder 1 or 5 by dividing by 6 always a prime number. It's not true. For example, we have 25. If you divide 25 by 6, you will get remainder as 1. But we know that 25 is not a prime number. but every prime number will give you remainder either 1 or 5. But we are not saying that every number which is giving 1 or 5 as remainder when we divide by 6 is always a prime number. It's not true. But every prime number except 2 and 3 will give you remainder either 1 or 5 when we divide by 6, right? So this is all about the prime number. So I will explain more concept related to prime number when I will cover complete number system topic. So this is all about the prime number. Now we have co-prime number, we have relatively prime number, we have twin prime number, then we have perfect number. So what are perfect number, deficit number and abundant number? I will explain. Clear? So this is all about the concept of factor, right? We have 6, right? We have 8 and we have 12, right? These all the numbers, right? We have 4 also. Clear? Now if we take the factors of these number, right? If we take the factor of these number, so the factors of 4 are 1, 2 and 4. The factors of 6 are 1, 2, 3 and 6. Now the factors of 8, 1, 2, 4 and 8. Now we take the factors of 12 is 1, 2, 3, 4, 6 and 12. Now what are perfect number, deficit number and perfect number, deficit number perfect number, deficit number and abundant number? Actually we have two types of factor. Actually we have two type of factor. One is proper factor, one is proper factor and another is improper factor. Improper factors. Actually number itself, the factor of any number itself is called improper factor, and except number, the factors are called proper factor, right? So the proper factor of 4 is 1 and 2 and improper factor is 4. The proper factor of 6 are 1, 2 and 3 and improper factor is again 6. The proper factor of 8 is 1, 2 and 4 and improper factor is 8, right? So what is the definition of perfect number? If the sum of all proper factor, if the sum of all proper factor, if the sum of all the proper factors of any number is equal to number itself, then your number is called the perfect number. Clear? So any numbers, if we have any number just like 6, I will explain on the next slide. 6. So we have proper factor of 6 as 1, 2 and 3 and improper factor is 6. So the sum of, if the sum of all the proper factor is number itself, so we have 1 plus 2 plus 3 is equal to 6, right? Or we can say that if the sum of proper factors and improper factor is same, is equal, then the number is called proper factor, right? Is perfect number. So this 6 is the perfect number. 6 is the perfect number. So the smallest perfect number is 6. I will explain more about the perfect number. We have 2-digit perfect number is 28. 28 is also a perfect number, which is a 2-digit perfect number. Now we have deficit number. If the sum of all the, just for example we have 4, if the sum of all the proper factor is less than the number, so we have 1, we have 2 and the improper factor is 4. If the sum of all the proper factor is less than the improper factor, then the number is called deficit number. So here we have 1 plus 2 which is less than 4. So this number is your improper number. This number is called improper number, right? So perfect number, if the sum of all the proper factor is equal to number itself, or the sum of proper factor is equal to improper factor, then the number is called perfect number. And if the sum of all the proper factor is less than the number, or less than the improper factor, then the number is called deficit number. Now we have abundant number, right? 12 is an abundant number. So what is abundant number? First take the proper factors of 12. Now the proper factors of 12 is 1, 2, 3, 4, 6 and improper factor is 12. Now just take here, if the sum of all the proper factors, is greater than sum of improper factors. If the sum of proper factor is greater than sum of improper factors, then number is called your abundant number. So you can see here 1 plus 2 plus 3 plus 4 plus 6. This is equal to 6, 16, and 16 is greater than 12. So 12 is your abundant number. Abundant number. So we have lots of concept in number system. We have very less time. So that's why I'm not taking other number also. So we have different types of number. Again, we have twin prime numbers, we have relatively prime numbers, we have co-prime numbers, abundant number. I have already explained. We will take so many example of abundant numbers, so many example of deficit numbers, so many examples of perfect number, right? But I will not take here. Now we will start our LCM.